Hi, I'm also Professor Primary 6 from YUMIN Primary School. In this time, let's revise what we have learned in the last lesson. So in the last lesson and the lesson before the last lesson, we have an example. This example, 1/3 plus 1 over 8 plus 1 over 15 plus 1 over 24 and etc. And we have used 3 different methods already. And with all these 3 different methods, well, the first method is a special method because for this example, you could actually use partial fractions. So this is special. But the other 2 are more general methods. Now, although these are more general, they might seem complicated and difficult. For example, in the last lesson, this method 3, it seems so complicated and so difficult, but it is general. So, in this method, we let a function, and in this function, we have to let it so that we could use differentiation, and then so we could remove this denominator, and that makes things easier. Because at first, when you write it into this sigma notation, you cannot straight away solve it. So this is method number 3. Next, we can have method number 4. So in each method, we'll see how can we use them and what type of methods do we have to use inside this method. Okay, so now I'll be moving on to method 4. Okay, and let me say one more thing. Usually for this part, this variable, we might not want to use I. So sometimes you might just use N, M, or other letters. So even if you change it, it is fine. So let me just change it at the same time. Okay. So let's start this method number 4. So method 4, we could change this into N. So that means we'll use N. But this time, it is not N, it is not N plus 1, but it is N plus 2. But N plus 2, we actually use this with this, so that, like, for example, if you use N, you realize you have to divide and times for this N plus 2. But what if you use here as N plus 2? Let's take a look at what happens here. So first of all, partial fractions. Partial fraction at first over n times n plus 2 becomes 1 over n minus 1 over n plus 2. But be careful at this part. When you common denominator, you have to get back the original fraction. So that means when you common denominator, you have to try it out. N plus 2 minus n. So there will be an extra 2. But at first we don't have a 2, so we'll need a half. At this part, you have x to the power of n plus 2. Now, you have this part. So what if we separate from one sigma into 2 different sigmas? Now, this part is, the power is n plus 2. I mean, here is a n plus 2. And down here is an n. Now, we want an n up here. So we have to remove this plus 2. But because this plus 2 becomes is actually x squared times the numerator. So you can take it to the front. So x squared. And now you have this part. So does it become simpler? Okay, let's see. So with this part, the numerator and the power of the numerator and this denominator is now the same. So you can start to differentiate and integrate. Because differentiation and integration, they are the inverse operations. So you integrate 0 to x. Then how about when you differentiate? So you have to differentiate this whole thing. Now let me write it out step by step. So let me just write this part a little bit clearer. Like this for the first term. Then the second term. Where I mean here is a half. Then integrate 0 to x. Then differentiate. Now you have to be aware that this x squared on the outside is not inside this part. So that means even after the differentiation, if you have like x squared, you cannot combine with them. You cannot take them out because inside here, it needs to go for integration. But over here, you don't need. So that means they are different. Okay. This part, then inside here, only the x to the power of n will differentiate. But since it is for this whole sigma, wait, here I still have the sigma. Differentiate power minus 1. So it becomes like this. Now what do you think of? What kind of method have we used for this part for the past two lessons or the past two methods? Well, that method is what we call it the sum for all the terms in a geometric progression. But what type of it is this? This is the GP, but it is with infinity terms. And this, at first, it is A times 1 minus the ratio to the power of number of numbers, then over. The denominator is 1 minus their ratio. But now this is infinity. So can we just let one thing? We could let this modulus x be smaller than 1. So that this will become a over 1 minus r. So it's the first number over 1 minus their ratio. So right now we just need this part. So that other part, we just let it be like that. So we don't need to care about it now. Now this part, so let's change it. So let's think. What is the first term? What if you sub n inside? So become 1. 1 over 1 minus, the ratio is 1 minus x. Then dx. Is it right? Okay, yes. Then you have to minus half. Integrate 0 to x. Now inside here is a bit different. When you sub n inside, the first term is x squared. Then over 1 minus x dx. So now this part, you don't need them. Okay, so it becomes like this. Now this first term is very simple. You can negative inside, then you actually notice it. So you'll need negative. Then over here is ln 1 minus x. Then start from 0 to x. But be careful. This x is only for this x inside this ln, because outside, well, you actually don't even care. So best way, you bracket these up. Is it okay? Then after that, at this part, now things are a little bit different. Here you can minus 1 plus 1. Then what happens? Partial fractions. Then simplify. But this part, there will be an extra negative, so it becomes plus. And this part is x plus 1, and dx. And behind, still a minus. So half, integrate 0 to x. Then what happens? So plus 1 over 1 minus x. So dx over 1 minus x. Then at this part in front, you can straight away sub in. Then this part at the back, you can integrate. Now, this you have x squared because of this first part x, but you have an extra half, so it becomes 1/4. There's a 1/4 x squared. Then you have to plus. Plus 1. Here's a 1, so that means it's an x, so it's a half x. And then here, sub 0 and x. Then at this part in the back, negative, be careful. This part is similar to the first term. Now what happens? Sub them inside. Okay, so this is your fx. Okay, yeah, this is your fx. But still, this is not the end, because this is a special case. This is you can say a special case, you can say a special form. But this is a general form. And this general form includes this special form. And this special form is where this general form x is 1. So we'll try to sub them inside. So here you need f 1. Now what is this equal to? First part. Well, first part. Here become a half. Here become infinity. It's a negative infinity. But this part in the back is an infinity. So this become an infinity minus infinity. Cannot. Then this part, 1/4, half, well, those you get submit inside. So first part, 3/4. Then after that, over there, plus half. Well, what is inside this bracket? Then you have ln 1 minus x. So inside here is actually, here you take both out, so it becomes 1. Here is left with x squared. So it's a 1 minus x squared. Like this. Now 1 minus x squared, what do you think of? Well, I think you'll most possibly think of a squared minus b squared. And that is right. But wait a second, I think something is missing. Well, of course, the limit. This limit. Or you'll need x approaches to 1 something. Is it plus or is it minus? Look at this part. Right now inside this ln, we don't know how to solve it if it is a plus. That means this is smaller than 0. So 1 minus here. So right now here half because it's a constant. So take it outside. Now it becomes like this. What can you solve here? Well, you can solve this part. It becomes a 2. So simplify with this part. Now it's like this. So afterwards, what happens here? You can put this at the denominator of the denominator. What kind of form are these? This form is 0 times infinity. And this form is infinity over infinity. Okay? So then, to this part, no choice left. Use L'Hopital's rule. Beware of this part. At first, this is to the power of -1. But then inside here, there will be another negative. So it's still a positive. So it becomes like this. 1 over 1 minus x over 1 over 1 minus x, then square. So negative, let's take it in front first. Then after that, at these parts, so you have 1 minus x. Then after that, what happens is that you can solve this inside. So it will become 3 over 4. So now it is a 3 over 4. So in the last lesson, we said because we don't want to write this whole thing, so we let it be x. So s would be 3 over 4. Like this. So s is a 3 over 4. Let's have our summary. Let's take a look. What's the difference between these two methods? What are the similarities between these two methods? These two methods, they are pretty similar. And wait a second. This I have said about inside the law, it's best for it to be positive. So let's also make this inside a positive. So that means you need minus 1 minus for all of these. Okay, so what others? Now you might have find that inside here you have this pattern. Inside here you also have this pattern. Now these two patterns, what's so special? So this constant, you can ignore it. So it just becomes limit x approaches to 1 minus. Then 1 minus x times ln 1 minus x. You have this that is equal to 0. Now what is this? So if you change the form, it actually becomes limit x approaches to 0 plus. Then x ln x is a 0. So what does this mean? Now there are many types of examples that you can have for this. Another example is well, it doesn't have to be a minus. For example, plus. Plus, you also can have it. It's just that this becomes plus. Now this plus is actually, for example, on that number line, this is negative 2 plus. But it approaches to this negative 2. Now, all of these is actually just this pattern. Now, which one decrease faster? X or ln x? Because x, it decreased to 0. Then ln x, it decreased to negative infinity. Well, this 0 I'm saying about is actually the infinitesimal. So, of course, is the x decrease faster. If it's a ln x decrease faster, then it will become a negative infinity. So this part, x. We will. Next time when you meet this kind of pattern, you go straight away sub it for a 0. And you're done. So for this, are you all clear so far? So I guess I could end this lesson here. So if you like our videos, don't forget to subscribe to our channel. So see you in the next lesson. Thank you for your watching.